Hey, welcome to this video on the triangle third angles theorem. So we're going to start by discussing what the third angles theorem is and proving it, and then we'll see how it's used in a proof. Sorry. Okay, so the triangle third angles theorem says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles or the remaining angles have to be congruent. So in this triangle, we have angle B congruent to angle Y, angle A congruent to angle X, which would mean the result would be that angle C is going to have to be congruent to angle Z. And that's because the triangles add up to 180. So if two of the numbers are the same in both of them, then the third numbers, when you subtract from 180, are going to have to be the same. And in fact, using the fact that the three angles of a triangle add up to 180 will help us to prove this. Now, this does not ensure the triangles are the same size, okay? Just the angles are congruent. The sides could be different. So you would need more information to know that the triangles themselves were congruent. All right, so we have our given information that we have these two triangles and that they share two angles in common. So we are going to say next that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And also the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180. That is because triangles have angle sum of 180, sometimes called the triangle interior angle sum. All right, the next thing I'm going to do is a little bit of substitution. Since A and X are equal, I'm going to put in an A in place of X right here. And since B and Y are equal, I'm going to put in a B for Y here. But first I have to say that their measures are equal by definition of congruence, because right now all I have is them being congruent. So that's the definition of congruent angles. And then now I can take my previous statement so I took this and I plugged in the appropriate angles by substituting. So I will write substitution. All right, and finally, I'm going to need to get them the same. So what I'll do is I am going to highlight this one and now this one because I'm going to move A and Y. Oh, I meant to make this a B, didn't I? Because I was supposed to be substituting for Y a B. I took out Y and I was supposed to put B in its place. So I accidentally copied the same thing again. Okay, so I'm going to take these two that I've just grayed out, and I'm going to isolate angle C in this one and angle Z in this one by subtracting A and B over to the other side. So I'm going to take this one and this one, and I'm going to say measure angle C for the top one is going to equal 180 minus A and B. That's subtraction. And then here, for this one, measure angle Z is equal to 180 minus measure angle A minus measure angle B, also by subtraction. So I kind of stuck it in the same step. Now I can say measure angle C equals measure angle Z by transitive, which means angle C is congruent to angle Z by definition of congruent angles. So we have now proved the angle subtraction, or I'm sorry, the triangle third angles theorem, which means we can now use it anywhere we need to without reproving it. All right, our next example uses that rule. So since we have these two angles here congruent, angle A and angle D, that means angle A is also 42. And 83 is congruent to the angle E in the other triangle, which means these remaining angles must be congruent. So this one is also 83. So that means this angle has to be equal to this one. So if I take 180 degrees and subtract the 83 and the 42, I'm left with 55 degrees, which would be both what angle C and angle F measure. And for our last example, we are going to do an example of a proof which uses the triangle third angles theorem. So we have FG is congruent to HI, that's given. We have FH is congruent to IG, that is given. And then we have those same sets of sides are parallel. FG is parallel to HI and congruent for the other ones. I did mark them a little bit incorrectly, so I'm going to fix that because it's bothering me. First, we were supposed to mark that they were congruent. Then we can mark that they are parallel. And these are parallel. All right, so I'm just going to stipulate the given. I'm not going to write it down all right here, and I'm just going to write given. Sometimes we number the steps, sometimes we don't, especially if they're not in a nice chart like this, you need to number them. All right, so I need to show some more things in these triangles are congruent. So I am now going to say HG is congruent to HG by reflexive. Actually, I have to go in order of corresponding parts. I'll call it GH. And then I have some alternate interior angles that I can list in my proof that are congruent. I'll call these angle 1 and 2. And angles 3 and 4 are congruent. Alternate interior angles. And then finally, because two sets of angles in one triangle are congruent to two sets of angles in the other, I can use the triangle third angles theorem. Which means I have all three sets of angles and all three sets of sides congruent. So I can say the triangles are congruent. Triangle FGH is congruent to triangle IHG by converse of CPCTC. So that is the end of this lesson on the triangle third angles theorem. Join us for the next one when we learn side angle side and side 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 triangle congruence criteria.